signal, as the small signal term comes, we are going to use for amplifying small signals at radio frequencies. So small signal means the input to your amplifier is 50 millivolt. It is very, very small. It is going to be in the active region of your transistor. The 50 millivolt can entirely cover the active region of your transistor. So whenever the term small signal comes, the input to your amplifier, it is denoted by this small signal. So small signal amplifier means the input to the amplifier is in the order of millivolt, not even volt. It is in the order of tens or hundreds of millivolt. So when you have millivolt input given to your circuit, the power consumption will also be in milliwatt. So in such case, I can clearly operate them in class A operation without uh, burdening the transistor. So in class A, the Q point is exactly in the middle, and class A is the only amplifier which has very, very small distortion. It is highly linear amplifier, right? So small signal tuned amplifiers mostly operate in class A condition where the distortion is almost zero. Ideally, it is zero. Practically, it will be very, very small when compared to other categories. So when the term you say large signal tuned amplifiers, I am going to give a signal in the range of volt to my transistor. So the amplitude is very high, the power involvement is very high. So I'm going to operate them under either, I accept class A, you have so many types, class A, B, class B or class C conditions, right? So I'm going to operate the transistor in that operation. Class AB means, in class B, it is the Q point is exactly at cutoff. Class AB means it is between midpoint and cutoff. Class C is below cutoff. So depending on whether I'm going to use it for a small signal amplification or large signal amplification, I'm going to bias my amplifier circuit accordingly. So small signal will always work under class A condition, and large signal will always work under class AB or B or C, depending on whatever configuration you are going to use. So as you know, only in class A distortion is zero. When you compare class A, B, B or C, the distortion will increase. So distortion will increase, and the circuit will become mostly non-linear. And the speciality of the tuned circuit is it is going to work only at one particular frequency, F naught, right? So other than F naught, whatever distortion of frequency the circuit is generating, this tuned circuit will completely eliminate the distortion. So that is one point. This tuned circuit will completely reject all the other frequencies. The distortion is going to be the integer multiples of F naught. So F naught is your fundamental frequency. It is called as resonant frequency, right? So 2F naught is your distortion. 3F naught is your distortion. 4F naught is your distortion. In general, I can say it is N into F naught. Okay, N into F naught. They are also called by other name called as harmonics. Okay, so since your tuned circuit works only at F naught, other than F naught, from 2F naught to NF naught, whatever frequency comes inside your tuned circuit, it is going to eliminate that frequency by default because it is designed to work only at that particular frequency F naught. So indirectly, this tuned circuit will remove the noise from your circuit. So in the essential frequency, it will ensure that maximum gain is produced at F naught. At frequencies other than F naught, it is going to eliminate all the other signals. Okay, and that is going to be the explanation for small signal and large signal amplifiers. So any queries, if you have, you can put up. We are still into the basics, so we are still, just discussing the basics of tuned amplifiers. We have not got into single tuned amplifiers. Okay, we have just seen what is a tuned circuit or how will a tuned circuit work and what is the behavior of the tuned circuit for frequencies. We have seen all those things. So any queries, if you have, you can ask. Okay.